In this video, we're going to talk about the measures of central tendency. So the median value of a set of data is the middle value and divided the value into two equal halves. So median is the middle of the value. So to begin with, if you have a sort of data, a set of data set, the first thing you want to do is to sort out the data. You want to order it. We order from the biggest value to the smallest one, order from the smallest one to the biggest one. So here, this one is already ordered. So for odd number of values, the data set A, we have 1, 2, 3, 4, 5 data in here. So our median is going to be the third data. Remember that before you do everything, your first step, you want to reorder the data. Okay, for even number of data, so we have 6 data, right? So the middle is going to be the half of the middle two, the half of the value of the middle two. So that means you want to take the average of the third and the fourth data, which means I have 12 plus 15 divided by 2, so I have 13.5. Then we have the mean of the data. So the mean is the average of the data. We calculate it by adding all the value and dividing them by numbers of value. So in here, we use the notation for population mean. Population means is all of the data. That the mean is going to use the notation mu. And for sample mean, sample is a portion of a population, we use x bar. So x bar is equal to the sum of x divided by the number of the data. So this notation looks like the opposite side of E is called the sum. Means you add in all the data together and then divided by n. N is the number of the data in your data set. So for example, in here, calculated the mean of these 3 data sets. So our x bar is equal to the sum, which is 3 plus 8 plus 12 plus 15 plus 18 plus 12, and divided by the size of the sample, which in our case is 6. We totally have 6 data. So in here is equal to 76 divided by 6, approximately equal to 12.67. Similarly to dataset B, we've got S bar equals to 3 plus 8 plus 12 plus 15 plus 18 plus 205 divided by 6. You might use a calculator to do that, and then you end up to get a 14.5. So you might notice that we are just replacing the 20 with 205, and then the average increase dramatically. Okay, now let's take a look how do mean, median, mode related to the shape of the distribution. So let's look back to our previous example. So in this data set, we have 6 data. So our mean, which is the average, is equal to 12.65, and for the second one, our mean is equal to 14.5. Now, what about the median? So the median is the center of the data, the middle of the data. In this case, it didn't change. So in here, it's going to half of 12 and 15, which is we calculated earlier, is 13.5. So in here also 13.5. So as you can see, if you have a little bit data that is extremely big, excessively unusual, that's what we call outliers, right? So 205 appears as an outlier. So see how outliers do to the data. As you may see, so if there is a outliers, if there's one or more outliers, it will change the mean, right? The mean is going to increase or decrease. It depends. Your outlier is on the left or on the right. In this case, it's going to increase, right? But it doesn't do anything to the median. The median stay the same. So that's why lots of time you will see when we calculate the average house income, when we talked about the house income, we don't talk about the mean. Most of the time we just talked about the median house income in Olympia area, the median house income of the US, the median house income of Seattle, because we don't want those outliers to affect our average, to affect how we're going to present in our data. So now take a look. Get back to this question, how the mean, median, and mode related to the shape of the distribution. So for symmetric distribution, think about it. Your median is not going to change, right? Your median and the mean is most likely at the center. So I would say the median and the mean, they should be close or the same. Now look at the skew left data. So look at our previous example in dataset B. So you have most of data. If we draw a graph, what does the graph look like? So most of data, if I draw, hey, this is 100, 0, 200. So most of data is going to be on 3, 8, 5, 6. 3, 8, 12, 15, 18 is going to on mainly accumulated on the left side of the number 9, right? And then suddenly you have a 205 on the right side of the number 9. So your data is going to be skew right. Okay, if we skew right, what happened? Well, our median is going to be what? Still remain the same, 13.5. So that means our median is going to be where most of data is, right? But our mean is going to be jagged to the right, because originally our mean is 12.68 if we don't have outlier, which is still close to where most of the majority of the data is. But once you add outliers, you suddenly, your mean is becoming in maybe here at where close to where is 50 is. So that means your mean is going to be on the left side. Your mean is going to be on the right side of your median if your data is skewed right. So in here, I can say, hey, the mean, it will be on the right side because the data skewing the mean, dragging the mean to the right side, because the tail dragging the mean to the right side. So for skew right data, mean is going to be on the right side of the median. Oh, sorry. So here is the median. Okay, so similarly to skew left, the tail dragging the mean to the left side. So the median is going to be where most of data is at, where most of data recurrence is, but our mean is going to be jagged to the left by the tail or by the outliers. So here is an example. Box office earning from Hollywood movies. As you can see, this data is skewed right. So that means we are expected the median value is going to be on where most of the data at. So the mean probably is around here on the right side of the median, because the tail again is dragging the mean to the right side. So as you can see, the conclusion that we have is going to be the median is resistant to the outliers, while the mean is not. The mean is going to be really affected by the median. So that's why, again, when we talked about the household income, we use median instead of mean. So for a frictional exam data set, how do mean and the median compare? So we just did it earlier, whereas the outlier 205, is going to drag in the data to the right. So in here, we can say, hey, the mean is getting affected by the outlier. The mean is bigger than the median, because the outlier 205 is dragging it to the right side. Okay, so now let's compare to these two. For these two different data set of a measure for the center and the shape, for scale distribution, you want to use median, because the median is resistant to outliers. Because when we have a scale data, the scale happens because we have outliers. So we want to use median, because median resistant to the outliers is not going to be affected by the outliers. We have two data sets to show you that, hey, no matter what outliers it, the mean remains the same. But if we have a symmetrical distribution where the mean is equals to the median, we will use the center. The center is going to be mean. In this case, how they spread out, we use standard deviation. Later we talked about what is the standard deviation. And for scale data, we use interquartile range, or something we call fine numbers theory. We will discover more as the class goes on.